Hello students, welcome to Solve This classes. Today we'll be solving the CSIR UGC NET questions from the June 2018 paper. We'll be solving the set C of the Mathematical Sciences paper. So let's start off with question number 70. In question number 70 it has been said that let Mn of R denote the space of all n cross n real matrices which are identified with the Euclidean space R of n square. Now if we fix a column vector x which is not equal to 0 in Rn, and f is defined as which goes from Mn of R to R as f of a is equal to inner product of a square x comma x. Then option 1 f is linear, option 2 f is differentiable, option 3 f is continuous but not differentiable, and option 4 f is unbounded. So we have to check out whether f is linear and then whether f is unbounded or bounded. Now for option 2 and 3 we can say that if f is differentiable, then we can definitely say that option 3 is wrong, and f is not differentiable, then we can definitely say that option 3 is correct but 2 is wrong. So we have to check whether f is differentiable or not from these two options. So let us start off with whether f is linear or not. Now we have been given that f of a is inner product of a squared x and x. So we can write that f of a is equal to inner product of a squared x comma x, which is nothing but ax comma a transpose x. This is what we know. Now let us find out f of a plus lambda b. Now let us find out f of a plus lambda b. So this will be equal to inner product of a plus lambda b x comma a plus lambda b transpose into x. This comes from this very part. Okay, so this will give us ax plus lambda bx comma a transpose x plus lambda b transpose x. So this will give us, upon solving, this will give us inner product ax a transpose x plus lambda into inner product ax comma b transpose x plus lambda into bx comma a transpose x plus lambda square into inner product bx b transpose x. So as you can now see that if we put, and this is not equal to, and this is not equal to inner product ax a transpose x plus lambda into bx and b transpose x, and we know that ax comma a transpose of x, ax comma a transpose of x is nothing but f of a. This is f of a, and bx by b transpose comma b transpose x, this is nothing but f of b. So we can definitely write that f of a, and this is equal to f of a plus lambda f of b. So since therefore f of a plus lambda b is not equal to f of a plus lambda into f of b. So we can see that from this relation that f of a plus lambda b is not equal to f of a plus lambda fb. So therefore we can say that f is not linear, and this implies that option 1 is false. Option 1 is false. Okay, now we'll shift our focus to whether f is differentiable or not. So for checking whether f is differentiable or not, let me insert another page over here. So now we'll find out whether f is differentiable or not. For that we have to find out the limit of f of a plus tb minus f of a upon t as t tends to 0. So this will give us limit t tends to 0. Now we have already found out f of a plus lambda b, so this will be equal to inner product of a plus tb. Let me write it down over here on the downside in a better way. T tends to 0. So this will be equal to limit t tends to 0. Now we have already found out f of a plus lambda b, so we will use that value to find out f of a plus tb. So this will be inner product of a plus tb into x comma a plus tb transpose into x minus inner product f of a will be equal to ax comma a transpose of x, and on the denominator we have t, and this will come down to limit t tends to infinity t into inner product of bx comma a transpose x plus t into inner product ax comma b transpose of x plus t square into inner product bx comma b transpose of x. Now if you are wondering that from where I got this value, as you already know, as you already have shown you previously that we found out the value of f of a plus lambda b. So using that value and upon subtracting this value, let me go backwards and then I can show you. So in the initial page we already found out f of a plus lambda b is equal to inner product ax comma a transpose x plus lambda into ax btx lambda into bx atx a transpose x not atx and lambda square into bx into b transpose x. So if we subtract this is basically f of a, this part over here is basically f of a. So if this part we take over to the left side, so this will be f of a plus lambda b minus f of a will be equal to lambda into inner product ax comma b transpose x plus lambda into bx comma a transpose x plus lambda square into bx comma b transpose x. The only change that happened in the part where we are checking for differentiability, we put t in place of lambda. That is the only difference that happened. So now let us shift back to this problem. So from that very sequence we got this result. Okay, so now if we cancel out t from t from the numerator and the denominator, this will give us inner product bx comma a transpose x plus inner product ax comma b transpose x plus t into inner product bx comma b transpose x, and there is 1 in the numerator in the denominator. So if you put t equal to 0, this will give us bx comma a transpose x plus inner product ax comma b transpose of x. So as you can see, this is very much possible. So we have found out the differentiability. So therefore f is differentiable. So if f is differentiable, that means that option 2 is true, and option 3 we said that f is continuous but not differentiable is false. So option 3 is false. So these are the two options that we have got. Now let us check for the fourth option. The fourth option is that f is unbounded. Now if we have to check out whether f is unbounded, what we'll try to do, we'll try to take, let a be the identity matrix. So that will give us, if we find out f of I, so this will give us inner product of ix comma basically this is ix into I transpose of x. So this is basically equal to ix, I transpose is again ix. So inner product of ix comma ix is nothing but equal to mod of x whole square. Now as mod of x tends to infinity, that implies that f of I will also tend to infinity. So if this is the case, if f of I tends to infinity, then that implies that f is unbounded. And if f is unbounded, that implies that option 4 is true. So therefore the correct options over here are, so therefore correct options are option 1 where it said that f is linear is false, so that is gone. Option 2 which says that f is differentiable is correct. Option 3 which said f is continuous but not differentiable, that is incorrect. And option 4 which said f is unbounded is true. So the correct options are option 2 and option 4. So these are the correct options. So today we have solved question number 70 from the CSIR UGC NET question paper of June 2018. We will be solving the next questions in the subsequent videos. Till then, keep watching Soft Classes videos for more solutions and content. Thank you very much.